LeetCode problem number 200, number of islands. So this problem gives us a m times n 2D binary grid, which represents a map of 1, which is the land, and zeros, which are the water. And our job is to return the number of islands. So here it explains what an island is. Basically, it is surrounded by water and formed by connecting adjacent lands horizontally or vertically. And all four edges of the grid are all surrounded by water as well. So if you look at this example, you can see over here, like these four are islands. So this is basically one island. So this here is basically one island, this is one island, and this is one island, right? Because for example, this one, it's surrounded by water, and this one surrounded by water as well. And since the edges, it says we can assume that they are all surrounded by water. Okay, so this problem will obviously require some sort of a flood fill to change the grids, to change the islands that we have explored into zeros, so that we would not revisit them. And if you don't know what flood fill is, it's basically you start at a point, can be any point, for example over here, and then what you will do is you will turn this into another character, and then once that is done, it will recurse and change the adjacent one, and once that is done, it will change this, the rest are right. So in a way, flood fill kind of is a depth first search, because it is always starting at let's say it's going down, it is always going down, and once it cannot go down anymore, then it will go to the right and go down from there, right? So the code for flood fill itself is pretty simple. Here you have the boundary checking. Here I'm checking whether or not the R and C value, which are the X and Y value, falls outside of the grid size. If it does, then we can just return it. Or if the grid we are looking at is not one, right? It's not the island, meaning we are looking at a water, for instance, then we are not interested in it, we can just return. Otherwise, if we found a grid that is 1 and falls within the grid, then we'll change it into another character. Let's say I put here X. It can be 0. You can use back the water as well, since we are only checking whether or not it is not equals to 1 over at our boundary checker. And once that is done, we call the function recursively again. This time our row -1, row +1, column -1, column +1, right? So for example, over here, row -1, it will be over here, +1 will be over here, column -1 over here, column +1 over here, right? So you will check all these cells, and then from there you recurse. Let's say it goes here, you recurse and check all these as well. Okay, so that's our flood fill function, pretty standard function. Here I have a for loop that iterates through every cell in the grid, right? So every cell in the grid, and if any cell is a island, then I begin the flood fill from there on. For example, here I'll begin the flood fill over here, right? And what this flood fill will do is change all the adjacent ones into X, right? You change all the adjacent ones into X. Let me draw it out so it's easier to visualize. So example, we have this, right? Maybe if I remove the, easier to see. Okay, so with this, so since I'm starting over here, I'll change it into X, and then I explore the left, right, up, down, X, and then X. Okay, once that is done, over here, I explore left, right, up, down as well. So we have to remove this as well. So once that is done, we had basically removed or marked an island as visited. And yeah, we have marked an island as visited. Then we continue on. Before that, we will increment our count, which means we have found one island. Then we increment and go to the next one, which is over here. Turn this into X. Increment our count again. Then we go to the next one, which is over here. Make it into X. And then the third field recursion. Change this into X as well. Increment our count. So count, we have 3 islands here. So 1 here, 2, and 3. After that, we just return count, which we get 3. Okay, this is a relatively simple problem using third field depth first search. Alright, that's all I have to show. Thanks.